Welcome to the next video. I really believe that there is a possibility that you must be already aware of drafts and the importance of drafts in plastic modeling or castings. Now the point is, if you're not aware, maybe this video will help you to understand the importance of it. Okay, now I cannot dive into the manufacturing processes because that is beyond the limits of this course, but the important point what we have to understand is that there are two main things when we are manufacturing the castings or plastic molding parts. Okay, you will be having a core and cavity. Okay, so these core and cavity form the shape of the profile which we are trying to manufacture. Like in our case, we are trying to manufacture the joystick cover or the switches, right? We are considering that all of these are being manufactured with the help of plastic manufacturing processes that has cores and cavities, which allows us to push the material inside those cavities and allow it to cool down. Then we will just pull the material out from those cavities, and we will use the manufactured material for manufactured part for some purpose. All right, now if I simply type in Google draft in plastic molding or draft in castings, anything, okay, you will be getting many images which will help you to understand. Okay, so obviously the credit will go to those websites which are showing these images. Right now, for example, if you're looking at this image, okay, now you can see on the left hand side we have a part which is drafted. So this is the part that they want to manufacture, and we have another part which is a non-drafted part. Okay, and we have this part which is a kind of extruded shape. This is called as a core, and the hollow shape is called as a cavity. So we have this core and cavity on both the up and low positions. Okay, and the core and cavity comes together, they form a gap between them, and that gap is filled with the material, and that material is allowed to cool down. After cooling, the material is pulled out. All right, now when we are pulling the material outside, imagine if it is a non-drafted one, what is going to happen? The material will scratch with the cavity and the core. Okay, so it is scratching between them, and it sometimes stick to it. It's not possible to pull it out, and in that process, when we are trying to pull it out, the material gets damaged, or the part or the manufactured part gets damaged. All right, and in order to avoid all those negative reasons or negative things which will be happening without the draft, we will be adding the drafts which will easily help us to pull out the part. Okay, you can see in this image, when it is not drafted, it is not easy to pull out, and when it is drafted, it is easily coming out from the core, from the cavity, right? And there are many images you can see over here. Again, this one you can see, when it is non-drafted, see, it's not coming out. It's not possible to come out. Okay, so we have to add some draft, then it'll come out. And you can just check up many images and try to understand what is the importance of draft. Okay, and what is the amount of draft needed. It depends on the parts thickness, material, and many aspects. All right, so this is the main thing. A draft model is required. You can see again over here, when these are coming together, they form a gap, and between them the material is filled inside, and it is easy to remove because it is a drafted part. All right, and when it is straight non-drafted, it is difficult to remove it. All right, so this video actually tells very in a very good way. So you can just type injection molding 101 colon draft angles. I have seen this video many days back. I remember right now after seeing this image. So he has explained in a very good way what is the importance of draft angles. So you can just check up that one and try to understand the requirement for a draft. All right, I really recommend you to watch this video. It's not like I'm promoting anything, but I really want you to understand the concept in a more proficient manner. All right, and this is the most important concept in any form of manufacturing, especially the castings and plastics. All right, so if you're working as a design engineer in these parts or in these manufacturing processes, then you definitely need to add drafts in your model. Without drafts, the model is incomplete. The supplier or the manufacturer will send you back the CAD data and ask you to update the CAD with drafts, relevant drafts. All right, now coming back to our part, the first and foremost thing is for you to understand how are we pulling the part. For example, if you're looking at this image, the part is being pulled in up direction, the top direction. All right, so we have to draft in a way that it is easily pulled outward. Okay, I'll come to this snip over here, and I'm sorry, did I open it? Yeah, snipping tool, new. Okay, so imagine if you have drafted it inward in this manner. Can you pull out? You cannot pull out the part because it was manufactured in this way, and after drying it will be, after cooling down from higher temperatures, it will be solidified in this shape. All right, and you cannot pull the material outside because it is jammed over here. That is the reason you have just gaps over here that will help you to pull the part easily outward. Okay, and this is being pulled in upward direction. All right, now if we look at the part which we have in our hand, that is the direction pad. If I'm going to a sectional view over here, we will consider that we are pulling out in upward direction. Okay, in this direction. So whatever walls we have, the vertical walls have to be drafted. That is the first thing. Okay, remember, that is the first thing. The vertical walls have to be drafted when we are pulling in the direction which we are pulling. The walls in that direction has to be drafted, the parallel walls. So you can see in this image the parallel walls are drafted, but this is not drafted. Okay, because this doesn't have any relation with the vertical walls. All right, so what we have to do is we have to first come back to our direction pad over here, and we will come to the section view, and we will see what are the vertical walls in this shape. All right, so these are the vertical walls what we have, and I'll just come back to draft. Let us consider only this wall. Okay, now the part is being lifted on the up direction. So do you think that the draft should be something like this, or it should be something like this? Okay, so the answer is the wall has to be in this shape, because when it is pulling out from the core, imagine this is the core. All right, so there will be a gap between them, and it easily comes out. But if it is in this manner, the part cannot be first of all, it cannot be built because that is a huge draft. Secondly, if it is created in this manner, then it will be jammed inside. It cannot be pulled outside, and it cannot be straight as well. All right, so the red color is the correct one. We have to add draft inside. Okay, we have to pull it inside. Similarly, if we are looking at this circle, okay, now for the circle, I'll just take a snip again. Same thing goes for the circle, because it is having a vertical wall, right? So it has to be drafted in this manner. I'm just drawing a rough sketch. Thickness of the wall like this, because when you're pulling it in upward direction, this can easily be pulled. It can easily be it can easily come out from the cavity what you have, okay, or the core what you have. Okay, if this is the core, it can easily come out from that core, right? So this is the reason we have to analyze what is the direction, then we have to create the drafts in that direction. Okay, so we will be adding the drafts now. So I will be going to model and select the draft, select this surface, right click, draft hinges. I'll select the base, I'll add 1 degree draft. Now you can see the draft is adding in the opposite direction, but I want it to be inside. I'll press OK. Now the trick is what, you just have to look from the top. So imagine if you're looking from the top, you must see this slanted wall, then it is perfectly drafted. Okay, but if it is on the other side, you cannot see the inside wall. That means it is an undercut. Okay, and undercuts should not be present when we have the for these parts actually. Okay, this is an undercut. So the trick is to ensure that you must, when you're aligning the part to the direction in which it is pulled, you must be able to see these walls, because the ribs are already drafted. You can see these walls, so this can be easily pulled out. That is the trick. Okay, And I'll just change the direction for this so that I can see the part in all the directions. So now, do you think that the walls, outer walls, are sufficient for us but not the inner walls? No, that is wrong. We have to add the draft for the inner walls as well. Okay, all the walls which are vertical to the direction has to be drafted. Remember that thing. So I'll select this, right click, draft hinges. I'll select the base, 1 degree draft. I'll change the direction inward. Now align to normal view. Now you can see, I can see the inner wall, I can see the outer wall from the top view. Can I see these walls? No, these are straight. That means if these are straight, when it is pulled upward, it will be having an issue. Right now, if I'm just aligning it to normal view, you can see that this is a drafted version. These are the walls. Walls are drafted right now, so it is easy to pull out. And we also have to add drafts for the outer walls. Remember that thing. Okay, the complete part should be drafted, and we will also be checking the draft analysis tool, which is the most important tool in Creo software, especially if you're working with these parts. So I'll quickly work on adding the drafts on other walls. Please work along with me. And I'll just go to the model, draft, select one wall, right click, draft direction, press this. We can also move the direction with the dragger. I'll just keep a 1 degree on the inside, and I'll just go to the surfaces, hold control and select the walls. Okay, so we can add the similar draft for all the walls in one go. Alright, the complete loop is fine. Now I'll just press the align to normal, and you can see all the internal walls are visible, isn't it? So we have the wall present over here, that is also visible, but we have to add a draft over here as well. Okay, remember that. But let us walk through to the other sides. So all are drafted. It's looking well and good. Now I'll just edit this draft again. Rather than creating multiple steps, I wish to use similar step and add the walls. Oh my god, Control Z. I forgot to press Control. So this is added. Okay, all the walls are added. Now, how do you check the draft analysis? We will be working on that in the next video.